What's going on, guys? Let's try this problem right here. Here we have a diverging lens with focal point of negative 25 centimeter, and for a diverging lens focal length is going to be always negative, and that's given by negative 25 centimeter. Also we have an object at 50 centimeter from the length, and the question here is asking us to find out the image distance. Now let's see how we can find it. First of all, let's draw the ray tracing diagram. But before we draw the ray tracing diagram, we have to know how it's going to be, like how is the ray tracing diagram is going to be, right? And here I have the sample right here. If you look at this one, what we do is we first we draw parallel to the normal, and when it hit the lens, we have to extend a dotted line from the focal point. So if you extend a line from the focal point, and if you extend that one further, that's going to be the refraction of this. That's going to be the divergence of the light, the ray of the light, right? So that's going to be the refraction of the light. And here that's the approach we are going to use right here. So first ray we are going to draw parallel to the normal, so this is going to hit the lens. After that, what we are going to do is we are going to draw a dotted line from the focal point and extend this one like this, and that's going to be the refraction. And then the second ray we have to draw is going to be, we draw the line that should reach this one. So we think like we are reaching a line that toward this focal point in the other side of the lens, and when it hit the lens, what's going to happen is it's going to go parallel to the normal. So it's not going to reach that one, right? It's going to go parallel to the normal, so the ray will go like this, right? Now the thing is, where is the image going to appear? So if an observer, so I have to draw an eye right here. Okay, if an observer watching this one from here, where is the image is going to appear? For a human brain, what's going to happen is, like, when for a human brain, it doesn't know the ray is refracting right here, right? So it doesn't know. So the human brain will think like the ray is actually come from here, right? So it's think like it comes from the straight line. So if you extend this straight line right here, this is going to touch right here, right? So wherever the line, these two line meets, there's going to be the image. So this is our image distance. Now we have to find out exactly what's the distance is going to be. To find that one, we can use this formula: S prime is equal to SF over S minus F. Now let's go ahead and do that. So this is going to be S prime is going to be SF over S minus F, and S is object distance, that's 50 centimeter, times the focal length, that is negative 25 centimeter, and then in the denominator we have S, that is object distance, that is 50 centimeter, minus focal length, that is 25 centimeter. So this is going to be minus 25 centimeter, and this comes out to be 50 times negative 25. That's going to give us negative 1250, and 50 minus 25, so that's going to be 50 plus 25, so that's going to be equal to 75. And if you calculate this one, you should get negative 16.7 centimeter, and that's going to be the image distance. Since we are getting negative answer, this means this is virtual image. That makes sense because we have the image exactly in the same side of the object. So this is front side of the lens, so this is a virtual image. So we can say this is virtual image. And to find out this is upright or inverted, we can use the magnification equation, and we know that this is already upright, but to prove this one mathematically, we can use this one. So this is going to be M is equal to negative S prime over S, and negative S prime is image distance, that is 16.7 centimeter, over S is object distance, that is 50 centimeter, and if you divide these two, that's going to give you the ratio, that is 1 over 3. So it means we are getting the positive, this is minus minus, so this is positive answer. So this means image is upright, and the magnification is 1 over 3. It means the image is going to appear 1 over 3 times of the original image. So it means smaller, like 1 over 3 times smaller. Like if you divide this one, that's going to give you 0.33. So it's going to be 0.33 size of this object, right? So that's how we do this kind of problems. I hope this helps. See you next time.